Good day everyone. In this lecture we are going to learn about the construction sequence of a silo. A silo is an important structure used for storing bulk materials such as cement, grain, coal, fly ash, sand and limestone. Since silos are usually tall structures, their construction requires proper planning and a systematic sequence of activities. Now we will understand the major components of a silo, different types of silos, factors affecting the selection of construction method and different construction techniques. We will give special attention to slip form construction, which is commonly suitable for tall cylindrical silos. A silo is a structure specially designed for storing bulk materials. Bulk materials are materials that are stored in large quantities without individual packaging. Examples include grain, coal, cement, fly ash, sand and limestone. Concrete silos are preferred when we need large storage capacity, a long service life and good fire resistance. A silo is not simply a storage container, it is a specially designed structural system that has to safely carry the weight and pressure produced by the stored material. Therefore, proper construction is very important. The construction method should provide adequate strength, stability, durability, and accuracy throughout the structure. Silos can be classified into different types depending on their shape, construction, and methods of storing materials. The major classifications are tower silo, bag silo, and bunker silo. A tower silo is generally a vertical, tall structure and is commonly associated with cylindrical construction. A bag silo uses a flexible bag-like storage arrangement, and a bunker silo is generally a lower and wider storage structure. Now let us understand the main components of a silo. The important components shown here are foundation, silo wall, roof, hopper, discharge opening and access and service arrangements. The foundation transfers the load of the silo safely to the ground. The silo wall forms the main vertical storage enclosure. The roof protects the stored material and completes the upper portion of the structure. A hopper may be provided at the bottom to help the stored material move towards the discharge point. The discharge opening allows the material to leave the silo. Access and service arrangements are provided for inspection, maintenance and operation of the silo. The selection of a suitable construction method depends upon several factors. First, we consider the diameter and height of the silo. Then, wall thickness, number of silos, site conditions are another important factor. If the construction must be completed quickly, the required construction speed becomes important. We must also consider the availability of construction equipment and skilled laborers. Continuous and reliable concrete supply is especially important when using methods such as slip forming. Finally, the reinforcement arrangement must be considered. There are several methods available for constructing silos. The main methods are conventional formwork, climbing formwork, slip form construction and precast construction. Conventional formwork uses forms that are installed, concrete is placed and then the forms are removed and reused. Climbing formwork can be moved upward in stages. Slip form construction is particularly useful for tall cylindrical silos because the formwork can move continuously upward while construction continues. Now we come to the main construction sequence of a silo. First, we carry out site investigation and setting out. This is followed by site preparation and excavation. Then the foundation is constructed. After that, the starter wall is constructed and reinforcement is installed. The slip form system and working platforms are then assembled. Once everything is ready, continuous concreting begins. The slip form gradually moves upward as construction progresses. After the wall is completed, finished and curing are carried out, next the roof, hopper and discharge system are constructed. Equipment is installed and finally the complete structure is inspected and commissioned. This sequence ensures systematic construction. The starter wall is an important part of silo construction. It provides the required base for installing the slipform system. Before proceeding further, several important checks must be completed. We must check the wall thickness because the wall must have the design dimensions. Reinforcement spacings must also be checked carefully. Adequate concrete cover must be maintained around reinforcement. The circular shape or circularity of the wall must be checked. We must also verify the vertical alignment of the wall. Finally, the concrete quality must be checked. These checks are important because any error in the starter wall can affect the accuracy of the entire slipform construction. Reinforcement is an important part of the wall. During slipform construction, the reinforcement must be continuously extended upward as the wall becomes higher. Vertical and horizontal reinforcement must be placed according to the design. When required, reinforcement bars can be connected using laps and mechanical couplers. The reinforcement must remain in its position while concrete is being placed and while the formwork is moving. Proper concrete cover must also be maintained to protect the reinforcement. One very important point is that reinforcement fixing must be synchronized with the slip form lifting rate. If these activities are not coordinated, construction may be interrupted and reinforcement placement may become difficult. The slip form system is the main equipment used for continuously constructing the tall silo wall. A typical system consists of form panels, yokes, vertical jacks, jack rods, walking platforms, suspension platforms, access ladders and material handling arrangement. The form panels provide the shape of the concrete wall. Yokes hold and support the form panel. Vertical hydraulic jacks help move the formwork upward. Jack rods provide support for the lifting system. Working and suspension platforms provide safe working areas for workers. Access ladders allow movement between levels. Material handling arrangements help supply reinforcement and concrete. All these components work together to allow continuous upward construction. The basic slipforming operation follows a continuous cycle. First, reinforcement is placed. Next, concrete is cast inside the former. The concrete is then properly compacted. After this, the form is gradually lifted upward. Finishing work is carried out on the exposed concrete surface and then the same process is repeated. The lifting rate is very important. It depends on the concrete setting time, temperature, mix characteristics, wall thickness and construction condition. If the form moves too quickly, the concrete may not have sufficient strength. If it moves too slowly, problems may occur with the concrete and formwork. Therefore, the lifting speed must be carefully controlled. During slipform construction, several teams work together at the same time. The reinforcement team places vertical and horizontal bars, maintains concrete cover and provides laps or mechanical couplers where required. The concrete team supplies concrete, places it uniformly inside the form and compacts it using vibrators. At the same time, the slipform team operates the hydraulic jacks, controls the lifting rate and checks the alignment of the formwork. These three activities are closely connected. If concrete supply stops, lifting may have to be affected. If reinforcement is not ready, construction can be delayed. Therefore, proper coordination between all teams is essential for successful continuous construction. Quality control must be maintained throughout silo construction. For concrete, we check workability, temperature, strength, compaction and curing. For reinforcement, we check bar diameter, spacing, lap length, cover and position. For the slipform system, we check alignment, lifting rate, stability and level. After construction, the finished wall must be inspected for thickness, verticality, surface quality and cracking. These checks should not be done only at the end of construction. They must be performed continuously because the silo wall is constructed progressively. Early identification of a problem allows corrective action to be taken before the problem becomes serious or affects a larger portion of the structure. Safety is extremely important during silo construction because workers may have to work at considerable height and around moving equipment. So this slide shows you several important safety measures. Guardrails should be provided at working platforms. Workers should use appropriate safety harnesses and safety nets where required. Proper lighting is necessary, especially during night work or in poor illuminated areas. Access ladders must be secure. Workers must use suitable personal protective equipments. Material lifting must be properly controlled to prevent falling objects. An emergency communication system should also be available. Every worker must understand the safety procedures before starting work. To summarize, silo construction requires proper planning, accurate construction, and continuous quality control. The most important idea to remember is that construction activities are connected to one another. The foundation supports the wall, the starter wall supports the slipform system, and reinforcement and concrete must progress together. During slipform construction, the form work moves upward gradually while reinforcement and concrete work continues. Finally, quality checks and safety measures must be maintained throughout the project. If you understand the sequence of activities and the purpose of each activity, the construction of silo becomes much easier to understand. Thank you for your attention.